Good morning. The purpose of this analytic is to look at the economic value of using sex semen in a traditional sense versus using it in combination with IVF technologies. Over on the left here, we have the main drivers that ultimately determine how many eggs a technician can generate from a supply of heifers. So if we envision that 35 animals could be processed per day, and those particular animals could be visited 8 times a month, and we aspirate 8 eggs per aspiration. This is going to generate a certain number of eggs per day, and the model is based ultimately on looking at how many eggs are generated per technician per 20 days. And in the model, it calculates about 5,600 eggs. Now, of course, not all of those eggs survive to become a heifer. We have a reduction; only 30% will get beyond the to day 7 post-fertilization, the blastocyst stage. And furthermore, we have different survivals to 40-day pregnancies, depending on how the transfer is made. If it's a fresh transfer to a recipient, we have the highest, about 60%. If we transfer them in a cool medium, we can get down to, this will drop down to 50%. And if we transfer them in a freeze-thaw in an embryo scenario, we're down to 40%. So these are different losses, if you will, rates according to how the ultimate embryo is transferred to the recipient. Now over here on the right, we have various costs per 40-day heifer. So this is the cost of having a heifer, a pregnant heifer, with a heifer calf, and it's the calf that we're interested in. So this is what we estimate the dollar value for a 40-day pregnant heifer. If we were to look at the traditional sex semen, where we're paying $50 a straw and we breed one animal and we have a 35% conception rate, then we're looking at about $150 per pregnant 40-day heifer. Now this is based on a sex semen harvest of about 95%. So you can see it's very expensive in the traditional way to generate additional females when we use sex semen on an individual animal. Now, if instead of using it on an individual animal, we use it on the eggs that we get from our harvesting from the cows, we can, of course, fertilize more eggs with a given straw. Now, the semen companies are going to charge more. In the model, the current model, we have it at $160, where we're using a ratio of $160 to fertilize 100 eggs. This number we don't know for certainty yet from the industry, and we need to, because this would be a patent infringement to use this technology in concert with IVF. But if we were to have a cost value of $160, then the cost per 30-day pregnancy is dramatically reduced. And you can see the varying levels. If we take the best scenario, we would be looking at $38 per pregnant heifer versus $150 in the traditional ways. And this over here would be the cost if we were to desire to have some 50,000 heifers. Now, in this cost is not only the reduction cost in semen, but also the cost to process the heifer, and that's based on an annual equipment fee of $73,000, $33,000 in supplies, $75,000 per year in technician, and this is based on generating 5,600 embryos per month, so it comes out to about $270 per egg, production cost. Now I have it in here at a default of 5. If we were to bring this down to 270 right there, you can see that it dramatically reduces the cost of that sexed heifer in a pregnant animal. And so we envision this as being one of the best ways to bring female progeny to the dairy industry of India. Furthermore, because there is such a large differential in cost per animal, we could actually envision bringing superior genetic animals at a low cost relative to the traditional way, and therefore enhance the genetic progress of the dairy industry. Thank you.